Welcome to Wildcat Science with Mrs. Haugo. This is physical science, and today we are working on 1.4, the magnetic force. This is part 1. So today we are going to be doing our pre-lab for the magnetic force. Please open up your book to page 8 and follow along. What happens when two magnets are brought closer to each other? Does the force between them increase or decrease? You have probably played with magnets in the past. You know that whether the magnets are pulling together or attracting, or pushing apart, repelling, the force between them will be greater when the magnets are closer to each other. But how does the magnetic force change as the separation between the magnets changes? If the separation between the magnets is doubled, what happens to the force? In this experiment, you will investigate how force and the separation of the magnets are related. And so there's a caution about our magnets. And the apparatus that you will use is shown in figure 1.4 over here. There are two cylindrical magnets. One is embedded in the base and the other in a dowel glued to a piece of string. Spacers are placed between the magnets to set the separation at which the force will be measured. All spacers except for the bottom two are removable, so you can change the separation between the magnets. The lowest two spacers are glued in place to prevent the magnets from getting too close. To find the separation between the magnets, you must know the thickness of one spacer. So let's look at this picture here. We've got a spring scale that's going to measure the force needed to separate these two magnets. Okay, looking at the question, how will you use the fact that all the spacers are the same thickness to find the most accurate value for the thickness of one spacer? And what is the thickness of one spacer in millimeters? And then you're going to create a data table containing the necessary columns and wear safety goggles. A spring scale can be used to measure the magnetic force, but first you must make sure that the spring scale reads only the magnetic force. The weight of the top magnet must be excluded. To do this, use the spring scale to hang the top magnet from the hook on the spring scale. Then adjust the spring scale to read 0 by turning the nut at the top of the scale. Looking at figure 1.1 earlier if you want to. You have now zeroed the spring scale for this experiment. Begin with a total of 8 spacers on top of the lower magnet. Carefully lower the top magnet onto the spacers as you hold the string. The hanging magnet will position itself directly above the base magnet. When you begin pulling up on the spring scale, the upper magnet will not move until the spring's pull becomes greater than the pull of the lower magnet. Looking at figure 1.5, you can see that they're pulling, but it's not enough force to pull the magnets apart. To observe the spring scale at the moment the magnets separate, call out the readings of the spring scale as you increase the upward pull. To improve your results, have your lab partner follow closely and repeat the measurement several times. Be sure to record both the separation and the force in your data table. Now, remove one spacer from the stack by one. Remove the spacers from the stack one by one and measure the force required to separate the magnets at each new separation. Make a graph with the magnetic force in newtons on the vertical axis and the separation of the magnets in millimeters on the horizontal axis. Then draw a smooth curve that fits the data points you have plotted. Remember that your curve does not need to touch all of the data points, and don't connect the dots. So again, looking at the figure, there's a person holding the spring scale and they're pulling up so that it is creating force on this upper magnet until it's enough force, it overcomes the magnetic force and they separate. There are a couple of questions. How would you describe your graph to someone who cannot see it? According to your graph, what happens to the magnetic force as the separation between the magnets gets larger? Now that we've read that section in the book, we will do our pre-lab. So please go to Classroom and open up 1.4 Prelab, the magnetic force, and it is actually a Google Slides document because we're going to do something a little bit different on this one. And once you have that pulled up, it should look like this. So the purpose, just like before, we'll double click on this, and then a text box jumps up, and you can take a guess at what you think the purpose of the experiment is, and write a full sentence ending with a period. So pause the video until you're done with that. And then moving on to the steps of this experiment summarized. So just like we would do in class, you will think of 5 steps of the experiment and type them in here. Again, double click in the text box, and then you can write your steps here. And pause the video, please, until you're done with that. Then it's time to do your prediction, and your prediction is down here, so you'll want to open up the text box, and you'll want to predict what happens to the magnetic force as the separation of the magnets gets larger. So as they are more separated, will the magnetic force increase or decrease? So you would say, I predict the magnetic force would increase or decrease when the separation between the magnets gets larger, period. All right, well, good job on that, and I look forward to seeing you when we do our experiment. All right, take care.